Hello everyone, welcome to my YouTube channel. My name is Turgut. In this video, I am going to explain how can you use text embeddings. Why we are using text embedding. They're really crucial if you are in some NLP tasks like text clustering or text classification like sentiment analysis or similar task. Why we are using text embeddings? They are definitely better than the word embeddings because instead of the single word, it just carries the semantic meaning of the whole sentence. And if sometimes if you don't have some words in your dictionary, word embeddings doesn't help you in your application. In here, and I'm going to show you how can you use text embeddings and how can you apply it. This is the first part of the video. In the second part, we will just find the data from the online internet, some Google reviews, maybe in some places, and then clean it and then apply it in some kind of web app. I will show you how. But in this short course, I will show you how can we apply it. In here, let me just a little bit make it bigger for you. Here, we were just importing OS model and JSON and base64, and just these are the important parts because I'm going to use Google Cloud environment. We need our credentials and for visualization, Matplotlib, and NumPy, and NLP cursor. And for environment, you need your project ID and just create another Py file. You can just import like that, or you can use OS module for that too. Let's just run this and importing necessary things. And you need to make sure there's some libraries here. You need to install in your local computer. If you're using your local computer, just use pip instead of the Anaconda. In my case, it's just easier or cleaner, and sometimes Anaconda is crashing. Okay, let's just import the Google Cloud AI platform, which just we were going because we are going for embeddings. I am going to use last time I used Hugging Face embeddings. This time I will use the Google platform. It's just versatile. How can you use different environment in your case? It's just my keypad inside my local environment. Is just put some JSON file when you just take from the Google environment when you just create a key value pair and you can download it and use it here. And okay, so it's just we are just creating credential here, credential that from service account file. You are giving your keypads. This is my keypad. And scope is just Google. Scopes is just our Google Cloud platform, and this is if your credential expires, just refreshing it. Okay, this is my project ID. As I said, I just imported from the my Python file and region. I'm just picking the central one. Okay, just I'm initializing the Vertex AI client here, and make sure in your Google platform enable to Google Vertex AI for your project. Okay, here, let me run this one too. Okay, we gave the Google AI platform initialize our project ID. You need a project ID. You can just go to Google Cloud. If you have a Google Cloud platform, you are just saying create a new project, and if that's give you a new project ID. And location is, I said the region, and credential is credentials. Okay, and I'm going to use a language model for text embedding, as I mentioned, this one, Gecko. And I gave some examples here because I am planning to use another piece of place in my web app. This is as a starter. And there are some examples here. And let me just, Margarita's pizza with award-winning taste, a true classic, try our gluten-free Margarita pizza, keep classic taste, so on and so forth. You can read these examples here. Now we are going to get our semantic meaning of these words, text, and then compare them and make a visualization. It's just, okay, these are the embeddings, and just what we are doing in this code, we are just creating for embeddings empty Python list and input text and input text list pizza. We just put them in the list here. As you can see, we are doing the for loop. Each for loop, we are going one by one. And I'm sure you guys know the for loop. And we are saying embedding model that what was our embedding model? We just initialized here, get embedding and input text, and we are getting our values. And just we are appending those embeddings, this A and B, to our embedding list. Then we are just making a NumPy array for because I'm going to use PCA for visualization. PCA is basically, I will explain when I come, and you can see these are our embeddings. We have 6 different text here, and this is our output of our model when you just send the embedding model and just gives us this matrix, this vector. Okay, we have this. Now we are importing PCA. PCA is a dimensional reduction algorithm. When you just, just think about it, just close your eyes and think about it, you are in the 768 dimension. And now you can't visualize this high dimensional vector. What can you do? You can just decrease this their dimension to, we are going to do 2-dimension because we have 2-dimensional screen here, and then we will make a visualization. How it works in PCA, it's just that every dot, you can see every dot. We would just, let's say this is our 2-dimension, and our dots are scattered around to this dimension. We are just basically measuring their distance to this 2-dimension and just getting their 2-dimensional value as just accumulate them. This is how PCA works. In detail explanation, you guys want, I know this StatQuest in YouTube, that channel is really explained well. You can watch that or just look some. Okay, in the PCA, we were just importing PCA from the scikit-learn. Scikit-learn is a machine learning library in the Python. It's just we are saying and components is 2. That means we are taking those 708 dimension to the 2-dimension. What happens? We are losing a lot of information. Don't do that in most of case. Just we are doing this for understand and to see the visualization here. Okay, we are just getting PCA model and just we are saying the PCA and components 2. PCA model fit embedding arrays. This is our embedding arrays. Then and PCA model transform embedding array. Now we are getting our new values. What are the new values? 6 different texts and 2-dimension. Now this is up. Okay, this is I'm creating here as just a visual with the matplotlib, and let me show you the values here, and let me show you. I was just saying the title and just get these are X values, these are Y values, and just make a scatter plot with X and Y. And this is the figure size, and these are my title, PCA embeddings, and this is our personal component 1, this is our personal component 2, and this is how it looks like. As you can see, 0 and 1 is really close to each other, 2 and 3 is close to each other, and the other ones are really far away from each other. Let's look at 0 and 1, what was those? Okay, as you can see, they are really similar to each other. Margherita pizza with award-winning taste, a true classic. Try our gluten-free Margherita pizza, keeping classic taste. These are, because these texts are containing similar words and their semantic meanings are close to each other. That's why when we visualize these tags, and as you can see, this embedding is really cool thing, and you can see those 2 tags as really close to each other. Let's say the 0 and 5 is really far away from each other. 0 means that our first one, Margherita pizza with award-winning taste. This is our last one, our spicy pepperoni pizza workshop hit among the enthusiastic. These are the different kind of pizza, and tastes are different, so we can see that their representation in our vector dimensions are really far away from each other, relatively the other compared. Okay, then we can there is a cosine similarity. We can use how similar these vectors each other, and there are different similarity methods. This cosine similarity is really works in this case. This is a just helper function, just getting the index of the first embedding, and then just getting the index of the embedding and just applying the cosine similarity here. Okay, and let's print first one, the second one. We are expecting that our cosine similarity is higher. If it's higher, they're close to each other. And just when I run this call, Margarita pizza winning taste, and second one is and it's contained these words and classic and Margarita, and you can see this one is 0.85. But we are trying now, and one with five. Let's try it. Yeah, one with five, and let's see, because they were in our visualization, they were close to each other. We were expecting that their cosine similarity is smaller. Okay, when we run this, as you can see, maybe not a big difference, but you can see their cosine similarity is smaller than the other one we tried, because they are their semantic meaning as far from each other. Okay, guys, this is the small explanation how we can apply embeddings, how they work to understand them. Then next video, we will just explore more, and we will get the raw data just online Google, and we will download it, actually scraping it, then clean it, then use for our application. Thank you so much for watching my video. Hope to see you next video.